the Formula Student Project is an engineering design competition where teams from around the globe design a single-seater Formula-style racing car, compete against each other at various competitions, both in the UK, Europe and abroad. The metal additive manufacturing has been really key in our airbox design. We've worked to get an airbox which has been 3D printed out of aluminium, and it's allowed us to really explore our designs, our geometries, and be more free with how we manufacture the product.
Renishaw have been helping us design our air intake for the race car this year. That's involved our student working very closely with Renishaw to optimise the design for printing.
So for complex parts such as this, additive manufacturing allowed us to go from CAD part data to manufacture in a matter of minutes. Compared to traditional technologies such as casting, where we'd have to create bespoke mould tools to do this, or fabricated assembly, we'd have to use multiple manufacturing methods to achieve the same effect. Once we had the optimised CAD data, we were able to then put it into our build preparation software, set up the build and transfer it across the machine, and this allowed us to manufacture the part very quickly and efficiently first time.
We had the air intake CT scanned on campus. That's enabled us to actually image and look through the material to see that it's densified really well, and the results look really nice. So we're very pleased with the actual final manufacturing process.
So the key benefits of additive on this project were we were able to take a complex assembly and break it down into just several key components. This allowed us to take a very complicated assembly which had multiple failure points and combine them into singular pieces and build them effectively.
The additive manufacturing has really simplified the actual finishing manufacturing, and we've split up the geometry and been able to assemble it through simple machining process.
So traditionally we would metal CNC machine the runners, then we'd have to do some welding on those, which is a lengthy process. And for the plenum, for the diffuser, we'd have had to have traditionally made moulds out of mill block, laid them up, cured them and then bonded them all together, which is quite a time and costly process.
It's been really great working with Renishaw on this project and learning about this advanced technology, and allowed us to build a really nice inlet manifold that should hopefully win us some good design points this year.
Work with universities and educational bodies gives us a chance to work with what we consider the next generation of engineers by allowing them access to technologies such as additive manufacturing at the early stages. It means not only can we help shape their understanding and train them, we can also help them research into new areas within additive and help benefit our understanding and help push the technology even further.